Today we will demonstrate the three-way handshake for the TCP connection establishment process. It is the method used by TCP to set up a TCP IP connection over an IP-based network. The handshake is a mechanism designed so that computers attempting to communicate can negotiate the parameters of the network TCP socket connection before transmitting data. We'll explain more of the scientific part at the end. After sitting in the library studying all day, Sarah decides she wants a break to grab some food with a friend. She wants to see if maybe her friend Megan wants to go grab some dinner with her later that night, so she decides to send her a message to ask her. Sarah writes a message to Megan and includes the SYN flag because this is the first message she is sending to establish a connection with Megan. Sarah then sends the message by giving it to a messenger to relay to Megan. The messenger brings the message to Megan. Megan reads the message and is all on board to go out to eat at Santa Fe at 6 p.m. with Sarah. Megan decides to write a response to Sarah to let her know she got her message and wants to go. Megan writes her response with the SYN and acknowledgement flags attached to it. She attaches the SYN flag because it is the first message she is sending to Sarah, and the acknowledgement flag to acknowledge that she received Sarah's response. She then gives her message back to the messenger to carry back to Sarah. Sarah receives Megan's response and writes her back a message to let Megan know she received the response and that they're good to go. Sarah gives the message to the messenger to carry back to Megan. Megan receives Sarah's acknowledgement message and a connection is established. Now both Megan and Sarah are sure that they both know to meet at Santa Fe at 6 p.m. And now for the boring explanation. Before the sending device and receiving device start the exchange of data, both of the devices need to be synchronized. The way to do this is called the three-way handshake. It is called this because 3 segments are exchanged between the sender and the receiver. Here we have a client as our sending device and a server as our receiving device, who of which will be establishing a connection. The client sends a TCP synchronized packet to the server. This is shown in our example when Sarah writes the first message to Megan. She included the SYN flag at the top of the message. SYN is short for synchronize, and it is a TCP packet flag that is used to initiate a TCP connection. It is a flag that is attached to the first message from each computer. ACK is short for acknowledgement, and it is a TCP packet flag that is used to acknowledge that they have received the previous packet. It consists of the sequence number of the next TCP packet that is expected to be received. The ACK flag is set to 0, and we set our initial sequence number to 3000 for this example. The initial sequence number marks the beginning of sequence numbers for data that the client will transmit. The objective of this packet message is to ask if the server is open for a new connection. The server then receives the packet and sends a SYN ACK confirmation. For this message, the sequence number is a random number that we set to 7. The SYN ACK packet that it sends back has an ACK set to 3001. ACK number is 3001 because it is telling the client that it is expecting to receive a packet with a sequence number of 3001. This is demonstrated in our example when Megan received the message and sent Sarah back an acknowledgement. She said, "Sounds good," to confirm that she received the message from Sarah and knows to meet Sarah at Santa Fe at 6. The client receives the SYN ACK packet and sends back an ACK acknowledgement. The sequence number of the message that is sent back is 3001. The ACK is 8. That is because it has received the packet with a sequence number of 7 and expects to receive a packet with a sequence number of 8. In our example, Sarah receives Megan's acknowledgement message and sends back a message that says, "Got it." This is another acknowledgement message that confirms that she received Megan's confirmation. The server receives the acknowledgement. This is shown when Megan receives Sarah's "Got it" message. After this, they are both on the same page and know to meet at Santa Fe at 6. After completion of the handshake, a TCP connection is established and the two devices can communicate and exchange data.